This conference will now be recorded.
In this session, we are going to deep dive into instance and database. We will understand more about instance and the instance structures and background processes. You know, Oracle instance has memory structures and background processes. So first, let us understand memory structures in detail. Oracle instance memory structures include SGA and PGA, System Global Area, and Program or Process Global Area. So first, let us understand SGA, System Global Area. So System Global Area, as the name indicates, system-wide. It is system-wide memory. All the processes can sharedly use this memory. On the other hand, process global area is specific to a particular process. Only that process can use that. So that's why it is private memory. SEA is shared memory. PGA is private memory. So first, let us understand SEA. SEA is very complex. There are many components inside SEA. So today we will understand all those components and other things. So first, SEA. So what is stored in SEA? SEA memory contains data and control information for one Oracle database instance. So when you create a database, you will have an instance. Each instance will have its own SEA. And when the instance accesses the data from the database, that data will be cached, stored inside SEA. And the controlling information, who has access to this data, who can modify this data, who can delete this data, who can query this data, all that information is also stored inside SEA. When the database is operational, various processes use this information to access the data. So that way SEA is a memory area that contains data and control information for one Oracle database instance. Every instance will have its own SEA. In a multi-instance environment, each instance has its own SEA. So when that instance accesses the data from the database, that data will be cached inside that SEA. So you can see in this diagram, this SEA is highlighted. This is the well-known picture to us, and this is your SEA. And SEA size can be configurable. When you create a database, during database creation, DBA specifies the size of the SEA. So meaning you can control how much a shared memory your Oracle database can use. And this memory allocation can be changed at any time. Okay, so today I created a database. I allocated say 1 GB shared memory. Tomorrow I can increase to 2 GB. Later I can decrease to 1 GB. So that way SCA is configurable memory. Anytime DBA can increase the size of SCA or decrease the size of the SCA depending on the requirements. So as more and more users access the database, as more and more queries are executed on the database, you might need to increase the size of the SCA. So that is possible. SCA serves various purposes, including caching data blocks read from the database. So data is ultimately stored inside the database, and the database is on the disk, right? So because database is all about files, any file is on the storage, the disk, but instance is in memory. So to speed up the data access, the data from the database is cached inside the memory. So that is the first one, caching data blocks read from database. Buffering redo data before writing it to online redo log files. As you make changes to the data, the redo data will be generated. Initially, the redo data will be generated in SCA in specific component called a redo log buffer. Then that is written to the redo log file, which is on the disk.
Okay.
Storing SQL execution plans. So when you issue an SQL statement against the database, Oracle internally generates something called execution plans. So for every distinct SQL, Oracle internally generates execution plan. And these execution plans are used to execute the SQL statement. So these plans are also stored inside SGA. And Oracle can reuse these plans when the same statement is executed multiple times. So instead of generating the execution plan every time, first time when an SQL statement is executed, issued, execution plan is generated, stored inside SGA, and reused that execution plan if some other user has executed the same SQL at a later stage, or the same user has executed the same SQL at a later stage. So that way, Oracle database optimizes the performance. Instead of doing the same thing again and again, it will reuse and optimize the performance. Then maintaining internal data structures that many processes and threads access concurrently. So while database is operational, many background processes, many server processes use various metadata about the database, like locks, who has a lock on this data, who has access on this data. So such type of internal data structures are also cached inside the SGA. All server processes and background processes share the SGA. So as we discussed earlier, SGA is shared memory. Oracle caches data, metadata, execution plans, okay, various other details inside the SCA. So all the server processes, all the background processes can use this data to process your SQL statements. So this is what is stored inside SCA at a high level. Now, all this information will not be stored in a single memory region. SCA is internally divided into various components. Each component stores a different type of data. So let us understand the components of SCA now. This diagram, this picture shows various components of the SCA. So you have database instance, which has SCA. SCA is the shared memory allocated to a particular database instance, right? Now, if you observe, this SCA memory has many components. Like here you have shared pool, flashback buffer, database buffer cache, in-memory area, redo log buffer, large pool, shared pool, streams pool, Java pool, and fixed SCA. So these are all the components of SCA. Now, some of these components are mandatory, compulsory. Every SCA will have those components. Those are represented with the solid lines. Like shared pool is represented with the solid line. So means this is a compulsory component. Now if you see flashback buffer is represented with a dotted line. So that means that is optional. It's not compulsory to configure flashback buffer. Similarly, in-memory area is not compulsory. But database buffer cache, redo log buffer again are compulsory. Similarly, fixed SCA is compulsory. So SCA has components. Some of them are compulsory, some of them are optional. You may configure those, you may not configure those based on the database environment and the requirements. So now let us understand all these components. Okay. In the theory guide that we are going to look at, you will have a detailed description of each of these components, what is stored in each of these components. For now, we will look at some of these important components, the mandatory components like shared pool, buffer cache, redo log buffer, fixed SCA. The first one is database buffer cache. Database buffer cache stores copies of data blocks read from data files. All users concurrently connected to a database instance share access to the buffer cache. Now, this picture shows you database instance, right, which is in the main memory of the database server, and database, which has files. So for simplicity, I am showing you one data file here. Now, internally, data file is formatted into blocks. Okay, each one is an Oracle block. Yesterday we understood the
Yeah.
data block.
Smallest
So
unit, yeah.
yeah, minimum unit of storage. So this data block may be 2 kilobyte, 4 kilobyte, 8 kilobyte, 16 kilobyte, or 32 kilobyte, because Oracle database can support multiple block sizes. Default one is 8 kilobyte. So when you create a database, the data block size by default is set to 8 kilobyte. So 8 kilobyte is the minimum unit of storage for Oracle database. So each one is 8 kilobyte, and data is stored in these regions. Now, data files are on the disk. So to speed up the access to the data, these blocks are read into memory. Which part of the memory? Database buffer cache. Database buffer cache, and stored inside the buffer cache and used multiple times. Suppose if two users need the same block, Oracle doesn't read it from the database two times. First time it will read and store inside the buffer cache. If the second user needs the same block, it will use from the buffer cache. By doing so, Oracle is reducing physical I/O. Physical I/O is disk I/O. And you know, physical I/O is time consuming and impacts the system performance. So if 100 users need the same block, Oracle will not read it 100 times from the database. First time it will read, store inside the buffer cache, and serve from the buffer cache. So that way, Oracle optimizes its performance by using SGA, by storing contents from the database into SGA. So once the block is read into the buffer cache, now you can see these red ones are your data blocks with data. Now this block is read into database buffer cache. Now after reading into buffer cache, you might change the data. You not only read the data, we change the data also, right? We modify the data. Suppose this block is modified. Okay, this blue portion indicates the changes made to the block. So that is what we are going to see in the next thing. Now, next component is redo log buffer. Redo log buffer, you know, stores redo entries. What is redo entry? A description of change made to the database. Redo entries contains the information necessary to reconstruct or redo changes made to the database by DML or DDL entries. Database recovery mechanism uses the redo data to reperform the transaction, to reconstruct the transaction. So let me just, I think this is overlapping. Database recovery applies redo entries to data files to reconstruct the lost changes. So now let us see. Now we have a block read into the database buffer cache. Who reads this block into the database buffer cache? Can you guess, Suma? Any idea?
The usually the server process, because the client wants
Yes.
this data to be read, so server process picks up the
Perfect. Yeah, correct.
Is that right?
Yeah. Yeah. So you know, when a client connects to database, Oracle allocates a server process. Server process is responsible for serving all the client requests, and some activities is directly done by the server process. Some tasks are coordinated with other background processes. Server process may not directly handle it. It will delegate that task to the background processes and coordinate with those background processes to ensure that the task is performed. Some tasks server process does directly. For example, to read a block from the database, server process will directly read it into the buffer cache. It doesn't use any other process to read. It directly reads the block. Now, now for the first block is read into memory buffer cache. Now, you or some other user may change some of the data in this block. So you changed that block now, right? Which is indicated with the blue color. Now, once you make changes to the data, you know Oracle generates a redo data for that change, a description of that change, which is recorded in redo log buffer. So that is the purpose of redo log buffer. So as you make changes to the database, a description of those changes will be recorded in the redo log buffer. Ultimately, these changes has to be written to online redo log files, which are on the disk. We'll see that later. Again, ultimately, once this block is changed, this block has to be written back to the database. So who writes all these changes back to the database? The background processes, which we will see at a later stage.
Okay.
Then the third component is shared pool. Shared pool is very important pool. It caches various types of program data like parsed SQLs, PL/SQL code, system parameters, and the data dictionary information. So in a way, shared pool stores the metadata. Okay. The privileges information, who has access to this data, and the parsed SQLs. Okay, when you issue an SQL statement, it is like a raw SQL. Oracle internally parses that SQL. Okay, and during parsing, it will know who has access to this SQL and kind of information. So the parsed SQL statement will be executed. So all the parsed SQLs and the PL/SQL code and system-wide parameters, right, and the data dictionary information. So this is all stored inside the shared pool. Shared pool directly doesn't store any data, but it stores metadata. So every SGA will have shared pool. Then the next one is fixed SGA. Fixed SGA, as the name suggests, its size is fixed by Oracle. You cannot, DBA cannot change the size. A small portion of SGA is reserved for internal housekeeping mechanism. And this fixed SGA is used internally by Oracle, and Oracle stores general information about the state of the database and instance, which is required by various processes to perform their tasks, and information communicated between various processes like locks. Okay, suppose one process holds a lock on a block. If other process need to change that block, it cannot change it unless the lock is released by the other process. So it has to know which process holds the lock. So the lock information, which is exchanged between various processes, is stored inside the fixed SCA. So every SCA has fixed SCA. So that way, these are all the mandatory components. As we discussed earlier, mandatory components are compulsory in every SCA. And apart from these mandatory, we have some optional components like flashback buffer, in-memory area, large pool, streams pool, Java pool. Suppose Java pool, as the name indicates, is used by Java. When you execute Java code against the database, the Java code will be parsed and stored inside the Java pool. Streams pool is used by another feature called streams, which is deprecated in 18C. So streams is an Oracle database option, which is used to replicate the data between two different databases. So when you configure streams to replicate the data between two different databases, streams pool will be used. Similarly, large pool. Large pool is used for large memory allocations. In-memory area, which is introduced in 12C. In-memory area stores data in column format to optimize the data warehouse performance. You know, in analytical applications or warehouse applications, column format is column format is better than row format. Row format is good for transactional systems, but in analytical systems, column format is optimal. So in-memory area is used to store data in column format and to speed up your analysis and queries. Similarly, flashback buffer is used by another feature called flashback technologies, which we will discuss in future. So these are all optional areas. Okay, an SCA may be configured to have these optional components or may not be configured. But these compulsory components, shared pool, buffer cache, redo log buffer, fixed SCA, are compulsory. Again, a DBA can specify the sizes of all these components except a fixed SCA.
Okay.
And those sizes can be changed as required. Or instead of you specifying individual sizes, you specify total SGA size and let Oracle decide the sizes for these individual components. So you are automating. You tell Oracle you use 1 GB SEA. Let Oracle decide how this 1 GB should be distributed among all these components. Out of 1 GB, Oracle may assign 200 MB to shared pool, 100 MB to buffer cache, 1 MB or 5 MB to redo log buffer, and say 100 MB to large pool, 400 MB to in-memory area. So like that, Oracle can decide that. So you are automating SCA management, or you can manually configure the size for each of these components. Oracle database has parameters called the initialization parameters. Using the initialization parameters, you can specify the size of all these individual caches or components. Or you can just specify the overall size of SGA and let Oracle decide the size of these small individual components. So it all depends on how you want to manage Oracle memory. Oracle memory can be
Okay.
managed in different styles: automatic memory management, automatic shared memory management, manual memory management, which we will see in
Okay.
next few slides. Then, so this is something about SGA. Now let us talk about PGA. Like SGA, PGA also has components. So let us see what are the internal components of a PGA memory structure. And before that, let us recollect the concept of PGA. PGA is a non-shared memory region that contains data and control information exclusively for use by server process and background process. Unlike SCA, which is the shared memory, which can be used by any server and background process, PGA memory is a process-specific memory. A server process can use PGA memory and the background processes can use PGA memory. And the information stored in that PGA memory is accessible to only that server process or only to that background process. That's why it is private memory. Now, what kind of information is stored inside PGA? PGA also stores various information, like information about the session. Suppose a user connected to the database. Oracle allocates a server process. So server process has to maintain the session information, right, throughout the operation. As long as the user is connected, the session information has to be temporarily stored somewhere. So that is the session information stored inside PGA memory. Then bind variable values. Your SQL statements may contain bind variables, right? So programmers may use bind variables to improve the efficiency of the SQL execution. So bind variable values will be passed to the SQL statement at runtime, at execution time. So till such time, Oracle has to store bind variable values somewhere. That somewhere is nothing but your PGA memory. Parsed SQL statements. Once you issue SQL statement, this SQL statement will be parsed and stored inside PGA memory. And at runtime, query execution state information. Okay, how many rows are fetched, how many rows are pending, that kind of information will also be stored inside PGA memory. So that way, PGA memory stores various information. Like SEA memory, PGA memory also has many components. So let us talk about these components. This picture shows you various components of the PGA memory. Like you have SQL work areas, session memory, private SQL areas. So PGA memory contains three components: SQL work areas, session memory, private SQL areas. So SQL work areas is used, this memory is used for sorting, hashing, and merging of the data. So when you issue SQL statements, data may be sorted, right, and hashed or merged data may be merged from different tables. So all that operations are performed inside this area. Then session memory, as the name indicates, stores session information, okay, like bind variable value, session information, which is used by the server process. Then private SQL area is used to maintain the query state information, okay, how many rows are fetched, how many rows are pending, all that information. So that way, like SEA, PGA also has components, and these components are used as and when required. And PGA memory also can be allocated by DBA. You can specify the total PGA memory that your instance can use, and each server process can use PGA memory. Each background process can use PGA memory. So at any point in time, the sum of all the PGA memories used by different processes is called as instance PGA. A DBA can specify the size of the instance of PGA. Like SGA size, DBA can specify PGA size. SGA size plus PGA size is nothing but Oracle memory size. Oracle memory is nothing but SGA and PGA sizes.
PGA.
Yeah. So now I specified SGA size as 1 GB. I specified PGA size as 2 GB for my Oracle database. So what is my total Oracle memory? 3 GB.
3 GB.
So total Oracle memory or total database memory allocated is the size of SGA plus the size of PGA. And this memory can be changed at any time. You can increase the allocation, decrease the allocation as per the changing workloads of the database. And this memory can be managed in 3 different styles. Automatic memory management, automatic stored memory management, automatic shared memory management, manual memory management. So Oracle memory can be managed in these 3 different styles. Let us talk about all these 3. Automatic memory management. As the name indicates, Oracle memory is automatically managed by Oracle itself. There is no DBA intervention required. Oracle can automatically manage the memory allocated to itself. So as a DBA, you specify the target size for your database instance memory. That's it.
Okay.
That is what you do. And leave rest of the things to Oracle. The instance automatically tunes to the target memory size, redistributing memory as needed between SGA and the instance PGA. So as a DBA, suppose you specified total memory size as 3 GB. That's it. That is what we need to specify. How do you specify that? Using instance parameters. When you create the database, you have something called a parameter file. Parameter file will have parameters. Parameters are individual settings for various components of the database. Now as a DBA, you will specify memory size or memory target as 3 GB. That's it. Now Oracle will decide out of this 3 GB, how much should be assigned to SCA, how much should be assigned to PGA. You don't need to specify that. So that way, as a DBA, you just specify the total memory your database can use. And your database decides how this total memory should be distributed between SCA and the PGA. The second style is automatic. In fact, automatic memory management was introduced in 12C version. The next one is automatic shared memory management, which was introduced in 11G version. Automatic shared memory management. What is a shared memory? Out of these 2, which one is shared memory? SCA. So that means you are automating the SCA management. This management mode is partially automated. You set the target size for SCA and then have an option of setting an aggregated target size for PGA or managing PGA work areas individually. So what you do in automatic shared memory management, you specify the size of SCA. Let Oracle decide the size for individual components of SCA. Right? So you specify size of SCA, you specify size of PGA. That's it. And Oracle will decide the size for individual components of SGA. You don't need to worry about how much should be the size for shared pool, how much should be the size for database buffer cache, how much should be the size for redo log buffer, and all that. Oracle will automatically decide that and allocate the memory, reallocate the memory as required. So that way you are automating shared memory management. Then manual memory management. So as the name indicates, you are managing the memory manually. Instead of setting the total memory size, you set many parameters, many initialization parameters to manage the components of the SGA and the instance PGA individually. So here, in manual memory management, you specify the size for each and every individual component, like database buffer cache size, shared pool size, redo log buffer size, Java pool size, large pool size. So you specify size for each and every component using various initialization parameters. So that way, Oracle supports 3 different styles of memory management. You decide which one is suitable for you, which one you prefer. Oracle recommends you to use automatic memory management, which will relieve DBA from the burden of calculating the size for each and every individual component. But if you are expert, if you have a lot of experience, you know how Oracle internally uses memory, you want to control that memory allocation, you may go ahead with automatic shared memory management or total manual memory management. So up to 10G, we have only manual memory management. 11G introduced automatic shared memory management, where you automate managing the SGA. Then 12C took this to the next level by automating total memory, SGA as well as PGA. So this is about the memory structures, the SGA and the PGA, SGA components and PGA components, and memory management. Now, the second part of instance is background processes. So let us learn more about the background processes now. Background processes perform maintenance tasks required to operate the database. Each background process performs a unique task, but works with the other processes. Oracle database creates background processes automatically when you start a database instance. So this is about background process. Every Oracle instance has many background processes. Some are compulsory, some are optional. Like memory components, background process is also compulsory and optional, mandatory and optional. Mandatory background processes are present in every instance. Optional background processes are started based on the database configuration. Some configurations may not use optional processes. Some configurations may use optional processes. So in this diagram, you can see the division: mandatory background processes, optional background processes, and a third category called slave processes. Some processes start slave processes to speed up the process, to speed up the work execution. So that's why they are called slave processes. As required, slave processes are started automatically, and once the task is finished, slave processes are closed automatically.
Okay.
So now let us talk about some of these processes. Again, I'm not going to discuss about each and every process. In fact, Oracle has many processes which are not shown here. Okay, in the material you will have description about each and every process. Okay, and from interview perspective also, nobody expects you to know each and every process, and it is not required to know each and every process. On day-to-day basis, some of these processes are used regularly. Some of these processes are started regularly. It is enough to know those processes. As you work more and more on Oracle database, you may know more and more processes. Okay, but initial stage, it is just enough to know the main processes that we are going to discuss now.
Okay.
Now, just to represent these processes in the overall picture, you can see here the big picture. So you have basically three components here. You have a client system on which your application is running, and you have a database server. And your database server has two components, database instance and the database. Now you can see the background processes which acts in the background, which runs in the background in your instance, right? So this DBWM, CKPT, LGWR, SMON, PMON, Archiver, Recover, and others. So these are all the background processes that we are going to discuss now, some of them. And apart from background processes, Oracle also allocates server process. So you can see SP here. SP is your server process. So when a client connects to database, Oracle database allocates a server process. Server process serves all the requests submitted by the client. Server process internally coordinates with the background processes and uses the memory structures to process the data. And ultimately, server process will coordinate the work and the result returns the results to the client application. So this is the big picture where you can see all these components present. Now, one difference between background processes and server process is what? Background processes are started along with the instance, and they will be continuously running in the background. When they have work, they perform that work and then keep quiet.
Okay.
Whereas server process is started when a connection is established and stopped when the connection is closed. But background processes, irrespective of the connections, they are started along with instance, they are stopped along with the instance whenever you shut down the instance. So that is the difference between these two processes. And the server process, background process can allocate PGA memory, which is not shown in this diagram. We are seeing only SGA memory, the shared memory.
Yeah.
So all these processes can temporarily store data inside the SGA and process that data and return the results to the client system. Of course, that is done by server process. So server process may not do each and every task. It depends on background processes. It coordinates with the background processes. But from a client perspective, server process is the whole and sole process that handles client requests. That's why it is called a foreground process. So as an example, other day we discussed a restaurant example. When you go to a restaurant, a server will serve your orders. But internally, server depends on other staff. Okay, in the kitchen, there may be a other staff. They does the actual work. But for client, server process is the single process serving all the requests. So let us start with understanding of some of the very important background processes. The first one is Database writer. Database writer. As the name indicates, it writes to database. It writes to database. It doesn't read from the database. Who reads from database? Server process. Now, what is this writing? You know, the server process reads the blocks from the database and stores temporarily inside the SGA in the buffer cache component of the SGA. Now you can see this diagram. We have a block, the red one, which is stored inside the buffer cache. Now you not only read the data, you change the data, you modify the data. So now somebody has changed this block. All the changes are done inside the memory first, then returned to the database to optimize the performance, because memory is faster, right? You can quickly process the data inside the memory. Disk is slow. So that's why Oracle reads the data inside the memory, changes the data inside the memory, and at a later stage, write these changes back to the database, which is on the disk. Now somebody modified this block. Now ultimately this block has to be written to the data file or the database, which is on the disk. Who does that? The database writer background process, right?
Okay.
Now you see this change is permanently written to the disk, meaning the data file. So that is the duty of the database writer. So it writes the modified buffers to the database. Modified buffers are also called as dirty buffers. They are dirty, right? They are modified. So dirty buffers or modified buffers in the buffer cache are written back to the database. That is done by database writer background process. In fact, you can configure multiple database writer background processes. The N represents the number of the database writer processes. You can configure up to 100 database writer processes. You can configure up to 100 database writer background processes. So N can be 1 to 100. DBW1, DBW2, DBW3, DBW100. You can configure, a DBA can configure multiple database writer processes to improve the writing mechanism, to speed up the writing mechanism. By default, only one database writer process is started. In a write-heavy oriented system, a DBA can configure multiple database writer processes to speed up the writing time, right? To speed up the writing process. So by speeding up the writing process, you are improving the overall performance of the database. The second one is log writer background process, LEWR. Now, log writer writes the redo data to the redo log file. Redo data or redo log entries to redo log file. What is a redo log entry or redo data? You know, when you make a changes to the database, a description of that change is captured in redo log buffer. Everything is initially captured in the memory in the SGA and written to the files at a later stage. Now you can see a change description represented in the blue rectangle. This is a change description. Somebody changed the database, some data in the database. A description of that change is generated and captured in the redo log buffer. And ultimately, this has to be written to the redo log file. Who does that? The log writer, right? The log writer. So that is the purpose of log writer background process. Log writer writes redo log entries to redo log files. So basically these two are writing processes: database writer, log writer. Database writer writes from buffer cache, log writer writes from redo log buffer.
Redo log
They
buffer.
write it to different files. Then checkpoint, CKPT. Checkpoint is a background process, okay, that makes these write time to time. It every now and then internally a checkpoint occurs. A checkpoint background process starts a checkpoint request by messaging database writer to begin writing dirty buffers. So at some intervals, all the modified buffers will be written to the database. To optimize the performance, as and when you modify the buffer, it will not be written immediately. Oracle database pull ups all these changes and writes them in one shot. Otherwise, for every change, if it writes, the database writer will be continuously busy writing, which will decrease the performance. So it will pull up the modifications and writes all of them in one go to the database. So that point is called a checkpoint. So internally Oracle uses checkpoint mechanism to start the writing. Internally checkpoints happen, and whenever checkpoint happens, the database writer will see what are the modified buffers in the buffer cache and writes all of them in one go to the database. On completion of individual checkpoint request, so who tells a database writer to write, to start writing? The checkpoint background process. It rings the bell. It rings the bell. Yeah, now is the time to write the changes. So that is done by the checkpoint background process. On completion of individual,
is there any one question? So is there any checkpoint parameter that TPS sets, like every 2 minutes or maybe every few seconds that checkpoint should run?
Yeah, correct.
Okay.
You can also control when a checkpoint happens at okay, many times. Okay, there is one parameter to control that. The timing also you can control how often a checkpoint should occur. Okay. So when we come to initialization parameters, I will talk about that parameter which you can use to control checkpoint.
Okay.
On completion of individual checkpoint request, CKPT, the checkpoint background process, updates the data file headers and the control files to record the most recent checkpoint. So this checkpoint information, okay, when last writing happened, will be recorded in control file as well as the data file headers. Who does this? CKPT background process. So CKPT background process, the checkpoint background process, does two things. It signals the database writer to write. Every now and then at certain intervals, it will ring the bell. Whenever it rings the bell, database writer writes the modified buffers. And after writing is completed, checkpoint background process records this information in control file as well as data file header, because the checkpoint information will be internally recorded in the control file as well as the data files. So that way during recovery, database knows up to what point the changes are captured into this database by looking at the checkpoint data. No need to perform all those changes before that checkpoint. Any changes made after the last checkpoint has to be reproduced. So checkpoint is also checkpoint information which is recorded in the control file as well as the data files is also very important during recovery mechanism.
Okay.
Next one is system monitor. See, as I told you, Oracle architecture is a big ocean. Okay, as you dig deeper, you will find a treasure. I can talk 1 month exclusively on Oracle architecture. That much big is Oracle architecture. But initially, just understand the overview vision, overview details. Because
Okay.
initial days, it is very difficult to understand the deeper details. As you dig deeper, it will be more confusing. Okay. Initially, try to understand the high level understanding of each component. That is good enough. As you work more, as you spend more time, you can understand the deeper, okay, about all these components. And as you dig deeper, you might be confused also initially. SMON, system monitor.
Yes.
SMON is also very important background process. It performs system-wide monitoring. It does many things. That's why it is called system monitor. There is another thing called a process monitor, which monitors only the processes. But SMON goes beyond a process and monitor overall system. For example, SMON creates and manages temporary segments. During query processing, temporary segments will be created in temporary table space. So who creates those temporary segments and who cleans up those temporary segments when the operation is done? The SMON background process. And SMON also maintains something called undo segments, which are created in undo table space. Undo segments are opposite of redo. Undo, redo. Oracle uses undo data, Oracle uses redo data. Now you know redo data. Redo data is required to reproduce a transaction. Undo data is required to undo a transaction, to roll back a transaction. So you will learn undo at a later stage. We have a separate topic on undo table space. We have a separate topic on temporary table space. All these things. So many of these components come at a later stage as a separate and individual topics. At that time, we'll spend more time and understand more about all these terms. So for now, just be aware that Oracle also generates, for every change that you do, Oracle generates a redo data, Oracle generates undo data. Redo data is used to re-perform the change. Undo data is used to undo the change, roll back the change. So who manages this undo data? SMON. Then SMON also cleans up the data dictionary. Okay. So when you drop an object, when you delete certain objects, the metadata related to those objects must be removed from the data dictionary, should be cleaned up from the data dictionary. That is done by SMON background process, and also maintains system change number. Again, Oracle internally has something called SCN number, system change number. Oracle internally tracks when a change was made to the database through a mechanism called system change number. For every change, Oracle assigns a change number. Oracle assigns a change number called system change number. So these system change numbers are maintained by SMON background process. So that way, SMON performs many tasks, system-wide tasks. That's why it is called system monitor process. PMON. PMON is process monitor. It monitors all other processes, right? You have many background processes. You have server processes. Pmon is the leader for all these processes. It monitors all other processes and performs process recovery when a process crashes or dies. Sometimes a process may crash because of a bug in the code, or a user abruptly disconnected from the database, right? Abruptly, not through the logout process. Normally, when you connect to a database, you have to gracefully log out. Okay, that is the graceful logout. Sometimes, suppose your system crashed, there is a power failure, you abruptly disconnect from the database. So whatever you are doing, okay, whatever changes you have done, whatever locks your session has obtained has to be cleaned up, has to be released by somebody in the background. That is nothing but your process monitor. So when a process dies abnormally, it performs a process recovery. Any data modified by that process, any locks hold, okay, in hold by that process will be released by process monitor. So that is Pmon background process. Then you have a new process introduced in 12c called LREG. This is introduced in 12c. LREG stands for Listener Registration Process. Oracle database has another process called listener process. In fact, this comes at a later stage in Oracle Net Services topic. You will learn more about a listener, you will configure listener, you will manage a listener in that topic. For now, be aware that Oracle also has something called a listener process, which handles the network connections. Okay, so when you configure Oracle networking, you start a listener. You means the DBA, whoever is the administrator of the database. Now, when listener starts, the database has to be registered with the listener. You configure something called database services. The services, the database instances will be registered with the listener. So whenever database instance started, whenever a service started, service handler started, LREG process notifies the listener that this service is started. In earlier releases of Oracle database, that is up to 11G, this work is done by Pmon only. Now in 12C, Pmon is relieved from this work, and Oracle introduced a new process called LREG. So these are some of the important background processes. There are many background processes, okay, which we didn't discuss. In the material, you can go through all those background processes. As I said, you don't need to know every background process. Some important background processes are enough, like we discussed database writer, log writer, SMON, PMON, all these things. These are the core background process, and initially it is enough to know these background processes. Later you will learn some other background. Suppose in archiving topics, you will learn about another background process called archiver. Okay, like that. As we discuss more topics, you might come across some other background processes. So that's it. That is the architecture topic.